VPN protocols determine exactly how data is routed through a connection. These protocols have different specifications based on the benefits and desired circumstances. For example, some VPN protocols prioritize data throughput speed, while others focus on masking or encrypting data packets for privacy and security. Now, there are two main approaches to VPN functionality. One, you could use two protocols, with one protocol used to move the data through the tunnel and the other protocol to secure that traffic. Or two, one protocol is used for both data transfer and data security. Here are 5 common VPN protocols and their primary benefits. The first on our list is PPTP, Point-to-Point Tunneling Protocol. It is one of the oldest VPN protocols. It is still in use in some places, but the majority of services have long been upgraded to faster and more secure protocols. PPTP was introduced way back in 1995. It was actually integrated with Windows 95, designed specifically to work with dial-up connections. At the time, it was extremely useful, but as technology advanced, PPTP's basic encryption was quickly cracked, compromising its underlying security. However, because it lacks many of the security features found in other modern protocols, it can deliver the best connection speeds for users who may not need heavy encryption. But while PPTP is still used in certain applications, most providers have since upgraded to faster, more reliable protocols. Put simply, PPTP gives the best connection speeds precisely due to the lack of security features when compared to modern protocols. When on a PPTP VPN, you get about the same connection speeds your ISP gives you. So for users simply wanting to watch Netflix from a different location and who don't really care about encryption, PPTP is still usable and not exactly dead. Number 2, we have L2TP paired with IPSec. Layer 2 Tunnel Protocol is a very popular VPN protocol. It is a replacement of the PPTP VPN protocol developed by Microsoft and L2F developed by Cisco. Various features were taken from both and improved upon. However, L2TP doesn't actually provide any encryption or privacy itself. In view of that, services that use L2TP are frequently bundled with security protocol IPSec. And once implemented, L2TP with IPSec becomes one of the most secure VPN connections available. It uses advanced encryption standard AES 256-bit encryption and has no known vulnerabilities, even though there's been claims of NSA allegedly compromising it. While L2TP with IPSec has no known vulnerabilities, it does have some slight flaws. For instance, the protocol by default uses the User Datagram Protocol UDP on port 500, and this makes traffic easier to spot and block by firewalls in countries where the use of VPN is frowned upon. Number 3, we have SSTP, Secure Socket Tunneling Protocol. Is another popular VPN protocol. SSTP comes with one notable benefit. It has been fully integrated with every Microsoft operating system since Windows Vista Service Pack 1. And this means you can use SSTP with WinLogon or for increased security a smart chip. SSTP uses 2048-bit SSL TLS certificates for authentication and 256-bit SSL keys for encryption. In all, SSTP is quite secure, but it is essentially a Microsoft-developed proprietary protocol. And this means nobody can audit the underlying code. For some though, they still see it as secure. Impressively, SSTP has native support for Windows, Linux, and BSD systems. And using third-party clients, you can also get users hooked up on Android, macOS, and iOS. Number 4, we have IKV2, Internet Key Exchange version 2. Is another VPN protocol developed jointly by Microsoft and Cisco. On its own, IKV2 is just a tunneling protocol, providing a secure key exchange session. Therefore, and just like its predecessor L2TP, IKV2 is frequently paired with IPSec for encryption and authentication. While IKV2 isn't as popular as other VPN protocols, it features in many mobile VPN solutions. And this is because it is adept at reconnecting during moments of temporary internet connection loss, as well as during a network switch, maybe from Wi-Fi to mobile data, for instance. IKV2 V2 is a proprietary protocol with native support for Windows, iOS, and BlackBerry devices. Open source implementations are available for Linux, and Android support is available through third-party apps. Unfortunately, while IKE V2 is great for mobile connections, there's strong evidence that the NSA is actively exploiting IKE flaws to undermine IPSec traffic. Therefore, using an open source implementation is vital for security. Number 5, which is my favorite any day for many obvious reasons, is OpenVPN. OpenVPN is an open source VPN protocol, and this means users can scrutinize its source code for vulnerabilities and possible exploit by state actors, and it can even be used in other projects. OpenVPN has become one of the most important VPN protocols. In addition to being open source, OpenVPN is also one of the most secure VPN protocols. OpenVPN allows users to protect their data using the essentially unbreakable AES 256-bit key encryption, amongst others, with 2048-bit RSA authentication and a 160-bit secure hash algorithm, or SHA-1. In addition to providing strong encryption, OpenVPN is also available to almost every platform: Windows, macOS, Linux, Android, iOS, routers, and more. Even Windows Phone and BlackBerry can utilize it, meaning you can set up a VPN on all your devices with it. It's practically the protocol of choice among VPN service providers. Of course, the OpenVPN protocol has faced criticism in the past due to low speeds. However, recent implementations have resulted in some boosts, and the focus on security and privacy is well worth considering, even if you have to lose a fractional and very negligible connection speed. While the method we'll leverage on to set up a VPN server in this course allows for all of these protocols, I'll be focusing more on the simplified use of OpenVPN. Of course, you are at liberty to employ whichever protocol among these that you consider more intuitive for you.